Hi class, I'm just going to quickly go over lesson 2 exponent rules with you. By the end of this lesson, the point is you're going to know how to simplify exponents using exponent rules and applying them to the variable. Okay, so we're just going to get started. From yesterday's lesson, you remember that when you're multiplying powers, or from the investigation rather, you remember when you're multiplying powers, you are going to add the exponents together. So when multiplying powers of variables with the same base, and you remember that it needs to be the same base. Add the exponents together. Okay, so if you have x and x here, you know you have x to the power of 1 times x to the power of 1. So you'll know you can do x 1 plus 1, so that'll give you x squared. Here you have 2x to the power of 1 times x to the power of 1. You multiply the 2 and the 1 together. That'll just leave you with 2. You take the x, 1 plus 1 gives me 2. Right? You have here 2x times 5x. Multiply the 2 and the 5. That'll give you 10. X to the power of 1 times x to the power of 1 is going to give you x, 1 plus 1. So 10x squared. Same thing here, 2 times 1 is just going to give me 2. Then I have x2 plus 1, so I'm left with 2x plus 3, times to the power of 3, sorry. Okay, so if you want, now is a good time to pause the video and see if you can go through these yourself and if you understand how to do them. If you're done, then come back and just watch it again. Okay, so welcome back. You're going to do -3 times -3, which is going to give me +9. X to the power of 1 plus x to the power of 2. So I'm left with 9x cubed. Okay, and then here I have -1 times 4, so I'm going to make that a -4. And if I take the variable, I have x to the power of 2 and x to the power of 1, so 2 plus 1, -4x cubed. Okay. And then last but not least, we have -2 and -8. So you always multiply the coefficients together. It's going to give me +16. And then I have x to the power of 3 times x to the power of 5. So it'll just be x3 plus 5. So +16 to the power of 8. Cool. Here we have 2x, -3y. Now I'm going to take the 2 and the -3 and I'm going to multiply those. Unfortunately, because x and y are not the same base, I cannot add the exponent. So this just turns into x, y. Okay. So now the rule when you're dividing powers is such that when dividing powers of variables with the same base, you subtract the denominator's exponent from the numerator exponent. Okay. So if we have something like this, this should not be here. So I'm just going to go in and just cross that out so that it doesn't bother us too much. But we have x over 5, x to the power of 1. So how I can write this is x5 minus 1, x to the power of 4. Cool. then I'm going to move on to here. So we have negative 12 and negative 4, and I know I can just divide these out. So negative 12 divided by negative 4 would just be 3. And then I'm left with the x to the power of 9. And in this bottom, I have a negative 2, so I can, or 2, so I can just do minus 2. So I'm left with 3x, 9 minus 2 is 7. Okay. Again, same thing here. When you're dividing, you can just divide out the coefficients. So we have negative 45 divided by 15 is going to give me negative 3, right? And I'm left with this k. And because I'm dividing the k's, I'm doing k7 minus 4, negative 3. 7 minus 4 is going to give me 3. And in case you're wondering why this happens, I'm just going to make a little side note here with our purple marker or pink marker, right? The reason this happens is because you have k times k because you have k to the 7, right? So 1, 2, 3, 4, 5, 6, 7, right? You have 7 k's divided by, and it says it's 4k at the bottom. So you have 1, 2, 3, 4, right? So just go ahead and cross out 1, 2, 3, 4. What are you left over with? You're left over with 3k's. So you know that your answer is negative 3k to the power of 3. And the k's are at the top, so it's not a negative. Okay? So let's do 4, which was the one that had actually gone off to the bottom over there, but it's 36m, 5, and 12 divided by negative 4m and 7. That's going to give me, I know 36 divided by negative 4 is going to be negative 9, right? M divided by m to the power of 5 divided by m means that it's going to be m5 minus 1. And then n to the 12 divided by n minus 7 is going to be n12 minus 7, right? So I'm just going to put everything in one line. And then 5 minus 1 is going to give me 4. 12 minus 7 is going to give me 5. So that is my answer. So I'm going to do one more that's a little bit more complicated with 3 variables. The rest of these, the solutions will be posted so you can go and check them out yourself. Try doing them yourself, okay? So here we have 9x to the power of 7, y to the power of 4, z to the power of 12. And then you have 18, x to the power of 5, y, and z to the power of 11. So first things first, let's reduce just the coefficients, just the numbers. So I have negative 9 over 18, which is the same thing as saying negative 1 over 2, right? And we're just going to extend that line out. So I dealt with my coefficients. Let's deal with my x's. So I have, So I have x to the power of 7, and then I have x to the power of 5. And I know since it's divided, it's going to be minus. Then I have y to the power of 4, and then I have just y at the bottom, so that's just 1. And then I have z to the power of 12, and then I have the 11 at the bottom. So I know it's going to be negative 1, I can just leave as is. So I'm going to make it negative x 7 minus 5 is 2, y 4 minus 1 is 3, z 12 minus 11 is 1. So I don't even need to write that, and I'll just leave it. All over 2. And that is my answer. That's just how you would do something a little bit more complicated. Just go variable by variable. Start with the coefficients and then just go left to right. Okay? So that's that. Now, rule for a power to a power. When you take a power and you put it to another power, what ends up happening is you have to multiply the two exponents together. You multiply the two exponents. This is different from multiplying variables, right? When you're multiplying variables, which was our first one, you're adding the exponents together. But when you're putting a power to a power, you're multiplying the two exponents of the same base together. So when you have something like, you know, x to the power of 7, bracket to the power of 7, now you got to multiply. You got to do x to the power of 7 times 6, and it's going to become x to the power of 42. Right? And that's only if your power is to a power. If this was x7 times, this was x7 times x6, you would do x7 plus 6 and blah, 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 blah. Okay, so that's an important distinction to make. When do you multiply? When do you not? Here you have negative 2x all to the power of 6, and you got to distribute that in. So you're going to do negative 2 to the power of 6, and then you're going to do x to the power of 6, right? So then you have 64x to the power of 6. So when you have a coefficient in front of it, you got to make sure you apply that 6 power to the coefficient. Same thing here, we have a coefficient of negative 2. So we're going to do negative 2 cubed, and then x cubed as well, right? Negative 2 cubed is just negative 8, x cubed. Okay, now this is where it gets a little bit more complicated. You got to do 3 cubed, so 3 cubed. And I'm just going to make it so that my form is always good. So bracket 3 cubed. Then I have x. The cubed is going to go there too. And then I have y squared. So y squared cubed. Right? 3 times 3 times 3 is going to give me 27. X cubed just simplifies to x to the power of 3. And then here we have y, 2, but all of that to the power of 3. So you're going to do y 2 times 3. Right? So that's going to give me 27 x cubed. Y 2 times 3 is going to be 6. And that's my answer. Okay. So coming back, I'm going to let you do all of these by yourself. I'm going to do example 5 with you because it's similar to what we just did, but it is more complicated. And then we'll do 7 together. And the rest of them you can do by yourself. Okay. So here we have negative 3. We got to cube that. Then we have x. We got to cube that. Then we have y squared. We got to cube that too. So negative 3 cubed is negative 27. Oh, it's the same thing. It's basically the same thing over there. It's just now you have a negative 27. Okay. Let's do 7. So when you have this, you know that you need to apply it to both because this is the same thing as saying 2 over 3 cubed. Then you have x squared cubed. So let's do 2 cubed over 3 cubed multiplied by x 2 times 3. Right, so 2 cubed is going to give me, I'm just going to do this down here, 8 over 27 multiplied by 8 times 6. So I'm just going to do it 8 like that. Okay, and then we'll do 8 just because it is a little bit more complex. We got to do an extra step here. So here we're going to go here. I'm going to say, all right, 7 times 3, right? Negative 3 to the power of 3 x 2 times 3, right? Let's simplify. So you have x 7 times 3 is going to give me 21 multiplied by negative 3 cubed is going to be negative 27. And then I have x 2 times 3 is 6, right? And then I can just, now you have this 21 multiplied by this 6. So I'm going to leave the negative 27, x 21 plus 6. So I'm left with negative 27, x 27. Right? Because first we did the power to the power, and then we had to find the multiplying two exponents together. So that's like an indication of what it's like if you multiply those steps. Okay. A zero exponent basically just means that when a number or variable is to the power of 0, it equals 1, right? So simply stated, 5 divided by 5, the reason that works is because if you have 5 to the power of 1 divided by 5 to the power of 1, you're basically just going to do 5, 1 minus 1, 5 to the power of 0. These two will still cancel each other out. You'll be left with 1. These will cancel each other out. You'll be left with, you'll be left with 1. Cancel each other out, 1. Okay, so if I had this, because it's to the power of 0, 1. Because it's to the power of 0, 1. Because this is to the power of 0, 1. Negative 1. Right, because it's multiplied by negative. Here we have p. And these are just mixed up fractions, so you can go ahead and try these on your own. If you have questions, just let me know, and we can post the solutions for these as well. They're already posted under lesson 2, so you can go check those out. All right.